We now know enough about turbines that we can begin to discuss how they're operated. Now, keep in mind during this segment that we'll be speaking in general terms. And the reason for this is that turbine operation varies from one manufacturer to another and often between turbines in a single plant. Well, the best way to learn turbine operation is by hands-on experience in the power plant. Obviously, we can't cover everything that an operator is responsible for here, but we can give you a few of the basic principles of turbine operation which you'll need to build on as you continue your training. There are 3 phases of turbine operation: startup, normal operation, and shutdown. As an operator, you'll have certain duties which need to be performed during all phases of operation, and certain duties which you must accomplish during specific phases of operation. To aid you in your work, most plants have specific procedures written down for the operator to follow. Let's take a look at a few of your responsibilities during startup. When a turbine is first started up, internal parts whose temperatures are around room temperature heat up to temperatures in excess of 1,000 degrees. If heat is not distributed evenly throughout the turbine, parts can expand in such a way as to cause the operator real problems. Now, in an earlier segment, we told you that close tolerances must be maintained within a turbine if it's to operate efficiently. The turbine supervisory instruments located in either the control room or beside the turbine unit allow the operator to monitor temperatures, expansion, tolerances, vibration, and other critical areas of turbine operation. Keeping a close watch on these instruments helps the operator to spot problems in advance and take steps to avoid them. A good operator always anticipates trouble and is prepared to correct it. Before a turbine can be run at full load, it must first go through a warm-up period. In this way, expansion can be controlled and turbine parts are not subjected to drastic temperature or pressure changes. During all phases of turbine operation, you will be required to take readings of turbine supervisory instruments. These readings should be in a log where they can be compared to normal trends of the turbine unit. Now, it's especially important during startup to keep an eye on the lube oil system's oil temperatures and pressures. By watching your units carefully and comparing current readings with the normal trends, you'll be able to spot potential problems, diagnose and correct them before they become critical. Shaft rotation and steam flow through the turbine are gradually increased during startup. In fact, there are limits on the rates that turbines are heated up, brought up to speed, and loaded. This is necessary so that temperature differences do not cause the turbine parts to expand unevenly or too quickly. The manufacturer's operating manual will provide you with specific information on how rapidly you can warm up the turbine and the necessary increments by which speed can be increased. Failing to follow the manufacturer's specification can result in such serious problems as cracking or fracturing of blades, wheels, or even the turbine casing. One final yet most important concern during startup is the prevention of water buildup in the turbine system. Because turbine blades rotate at tremendous speeds, a single drop of water impacting with a turbine blade can seriously damage the blade. Too much water buildup can cause the blades to fly apart. To prevent this, drains at various points in the turbine and its associated piping are opened during startup to drain out any water that results from steam condensing when it first comes in contact with the relatively cold turbine parts. After startup, the drains can be closed because by this time, the metal parts are up to normal operating temperature. During normal operation, turbine speed is stabilized and held constant. The operator then makes routine checks on the systems. As during startup, oil temperature and flow to and from the turbine bearings are checked periodically. Main lube oil pressure is also monitored. All readings are checked against normal trends of operation. Other routine checks include turbine speed and load, condenser vacuum, and main steam pressure. Shutdown procedures are similar to the procedures used in startup, except now the turbine is hot and needs to cool down gradually. Most of the concerns during shutdown are the reverse of startup. In preparation for shutdown, the operator makes a check of the turning gear to see that it's operating properly. Now, once that's done, shutdown can begin. And during shutdown, the control valves are gradually closed, reducing load on the unit. At a prescribed point during shutdown, drain valves are opened so that condensate from the steam will not build up inside the unit. At a second prescribed point, according to manufacturer's specifications, the turbine is tripped. As in all phases of operation, it's important for the operator to monitor the turbine supervisory instruments. Special attention should be given to the lube oil system. The operator must make certain that the proper amount of oil is being supplied to the bearings. Now, of course, the main concern during all phases of operation is the safe and efficient operation of the unit. After shutdown, the turbine shaft is kept constantly turning, at least until the turbine has thoroughly cooled. This is typically accomplished by starting the turning gear motor and by pushing a lever. Okay, now that you've seen how a turbine is operated, keep in mind that turbine operation is a complicated job, and you still have a great deal to learn. This unit has prepared you with basic knowledge that must be added to during actual experience in your power plant. You should now be able to look at the turbines in your plant and begin to make sense out of what's going on.